Hello. In the last class, we have discussed about the electrophilic substitution reactions, and we also discussed about aromatic electrophilic substitution reaction. So today, let's continue this aromatic electrophilic substitution reaction. Let us continue the reactions. So, in the case of aromatic electrophilic substitution reactions, we have discussed earlier in the last class that benzene itself is a nucleophile, so it undergoes electrophilic substitution reaction. So benzene itself reacts with an electrophile to give this product along with this one. So here hydrogen is replaced by one hydrogen atom is displaced by electrophile. Okay, so this is the addition followed by elimination reactions. Aromatic electrophilic substitution reaction is addition first, then elimination takes place. So benzene undergo electrophilic, aromatic compound undergo electrophilic substitution reactions. So here in this case hydrogen is displaced by electrophile. So here we can have discussed earlier also this last class also the mechanism of the general mechanism of the reaction is in two steps mechanisms. So first one is general mechanism of the reaction is there is hydrogen here, okay. So electrophile there, then first attacked by this benzene ring attacks to give a carbocation, and this intermediate is not aromatic now. This is not aromatic. So positive charge here, carbocation. This is first step of general mechanism. First step of mechanism of aromatic electrophilic substitution. So this carbocation can be delocalized in many ways. You can have so many resonance structures. So last time we had discussed this also. So you can have positive charge can be here again, and then again this can be delocalized like this. So you can have this type of intermediates. Okay, is positive charge here. So we can have these three can be have a general hybrid type of equilibrium type of this hybrid system we can have. So is here, E here, then you have like this. Okay, this delocalized the three here. So we can write a hybrid of this carbocation. So this is the first step involved, and then the second step, this carbocation is attacked by the loss of one proton to give this attack by base or loss of one proton. Just let's say this one, hydrogen here, and electron. Okay, put this charge here. Now this is loss of actually acting by base or loss of one proton. We can have this final product. Okay. So this is the second step of the reactions. So got a final product. So hydrogen is replaced by this product. Okay, by electrophile. Hydrogen is replaced by electrophile. So I'm repeating again in the last class that. So we can have slightly. Okay, look. So aromatic electro system, the mechanism of the is that the hydrogen is replaced by electrophile, and the mechanism is first step is benzene attacks the electrophile to give a carbocation. This carbocation, then second step loss the proton, and then to give the product. Okay, you can say ISB or like this also. If they attack by base, then you can have this one. So this is the overall mechanism, general mechanism of the aromatic electrophilic substitution reaction. So last time also we have discussed about the many types of reactions. There is types of reaction. For example, say let's discuss one by one. Okay, so we have discussed also last time. So the actually energy profile of the reactions of aromatic electrophilic substitution reactions. So we can have you can draw this thing. Okay, I will draw here the energy profile of the aromatic electrophilic substitution reactions. So you can have energy here, energy like earlier case, progress of the reaction, or reaction coordinate here, reaction coordinate or progress of the reaction coordinate. Okay, so this is the, you can write this way. Then we can have this fast like this. This is one. You can have two types of transitions that you can have. One here, another one intermediate here, and transition is another one. Then we have the product here. So product is lower than, so here the starting material benzene reacts with electrophile, and then this hydrogen is replaced by, and here product is benzene electrophile, and then okay, benzene electrophile E plus, then H plus. Okay, so this is the and then the first transition step 1. This is the transition step 1 and transition step 2. Okay, and this is the intermediate is, then we have the carbocation intermediate. Then you can write E. You can write this. Okay, so this is an L, is the intermediate. Okay, so this is the reaction profile, energy profile of the aromatic electrophilic substitution reactions. So we can have energy level from here to here, and higher here, and then higher lower. Okay, so you can have E1, E2 like that, delta E1, delta or delta E, okay, like this. So this is the energy profile of the aromatic substitution reactions. So we can earlier we can discuss. Now let us discuss all the types of reactions, that examples of aromatic electrophilic substitution reactions. So let us have. So earlier we have, the last class also we have talked about. So first one is types of reactions. So here examples of aromatic electrophilic substitution reactions. So first one is halogenation. Then the second one is, say, nitration, and third one is sulfonation. Then we can discuss this thing one by one. Okay, fourth one is Friedel-Crafts reactions. Crafts. These are alkylation, and then you can have fifth one is Friedel-Crafts acylation. Okay, so these 5 reactions we'll discuss one by one. So in this case, in the case of halogenation, that halogen is this electrophile is halogen. The hydrogen is replaced by an halogen. Okay, X. Hydrogen is replaced by X, and in the case of nitration, hydrogen is replaced by nitro group. Okay, NO2. I think you cannot see this one. I'll write down here. Nitration. The hydrogen is replaced by NO2. Okay, and sulfonation, sulfonic group. Okay, you can write this way. SO3H. Okay, sulfonic group, and Friedel-Crafts alkylations is reacts with RX in presence of, you can say R. Okay, alkyl benzene are formed, or arenes are formed, and acylation, you can acyl groups. Hydrogen is replaced by acyl groups. Okay, form a ketone. Okay, like this ketone. So this will be discussed one by one. So I'm repeating again, the last class we have discussed about the different types of examples of aromatic electrophilic substitution reactions. So we have halogenation, nitration, sulfonation, Friedel-Crafts acylation, Friedel-Crafts acylation. So let's say one by one. Let's discuss this one by one. Okay. So let's see halogenation. Halogenation means, so we have here electrophile. Here is halogenation. First, you can have halogenation. In halogenation, we can discuss this bromination, and then chlorination, then iodination. Okay. So first let's have this bromination of this uh, aromatic compounds. This is benzene ring reacts with, in the case of bromination, so here takes place with bromine in presence of a allylic acid or Br3. Okay, so acting as a allylic reaction, Br3 forms a species fast, so it gives the hydrogen is replaced by bromine, and the bromination takes place. So this is the product. So and then so this is the now hydrogen is replaced by bromine. So we can have the mechanism of the reactions. So first part you can have, so the products are you can have the product, other products are ISBR, then replace this, and again the catalysis is still coming out. Okay. So let's see the mechanism of the reactions, bromination reactions mechanism. First, this bromine. This bromine. Okay, we have 6, 1, 2, 3, 4, 5, 6. 6. Okay, reacts with this is Lewis acid, Br3, peg bromide. Okay, this is Lewis acid, is Lewis base now acting as Lewis acid and acting as the Lewis base. Acid base reactions. Okay, so Lewis acid, Lewis base. So first it gives a intermediate 1, 2, okay, like this. Here, so it gives given to attack to this iron. Okay, so you get Br, Fe, Br3. So now it comes, this becomes lost, this becomes positive charge slightly, and then it becomes the negative charge. Okay, so this is the first step. Then this one, Lewis acid base reactions of I'm repeating again, Lewis acid base reaction of bromine with a ferric bromide forms a species with a weak polarized Br bond. Okay, this can again this reaction the reaction with benzene ring. The second step it attacks the benzene ring. This let's say like Br Br3. Okay, so this is negative charge, positive charge. So now attacked by this will give this attack here, so they will give this one. Okay, so now we have an intermediate, a carbocation is formed, is Br, and then this is hydrogen here, this is positive charge. Now the cation is formed. So this cation, like earlier one we have discussed, can delocalize into this mini form. Okay, so you can have ice Br, so you can delocalize this way, and then we can have positive charge here, and then you can have another one. So this way you can delocalize this one ice Br. Okay, either in the para position, positive charge will be at the auto position as well in the para position. So these are all in a way discussed like this. So in the final step will be final step will be this carbocation is carbocation. Let's say this hydrogen and Br, then this hydrogen. Okay, positive charge here. So this reacts by this reaction. We have discussed this. So reacts with base acting as this one, Br and Fe, Br3. Okay, so negative charge here. So this will attack this form a hydrogen bromide ISBr, then neutralize this one. So the product will be this bromine here, this, and then this will be comes to double bond here, positive double bond, and then here we have hydrogen here. Okay, so this hydrogen is replaced by bromine. Then this we have FeBr3. That catalyst is replaced again. The catalyst is regenerated, and then we have ISBr. This one ISBr. So in this the mechanism of the formation of this alkyl benzene by halobenzene by reacting with this benzene with the bromine. Okay, hello. So the mechanism of the reaction is bromination mechanism is first step is the mechanism of the reaction is the Lewis acid base reaction with the bromine with a ferribromide to form a species which is weak base. So then this species are attacked by the benzene ring to give the bromination takes place. Then the bromine pick up the bromine, then you got this, and then this positive charge is formed. This are delocalized like earlier cases. Then finally this hydrogen is picked up by bromine to get the final product. So we got this halobromine, this bromobenzene to get the product. Okay, this is about the mechanism of the aromatic substitution reaction. Now let's discuss about the chlorination. Also same case we can discuss chlorination like earlier cases, chlorination, or similarly you can have similar type. You can discuss chlorination. Here also instead of bromine we can use this chlorine. Okay, so you can write aluminum chloride can be used here. You can write one here for chlorination reactions. Chlorination reactions. Chlorination. For here, so hydrogen is replaced by chlorine. Hydrogen is replaced by chlorine. Okay. Chlorination using this Lewis acid ferric chloride. Okay, so here chlorobenzene is formed like earlier as bromobenzene. So you can have hydrogen here. One hydrogen is replaced by chlorine, so the product is this one. Then you can have like earlier calcium case like bromination taps. So we can have mechanism of the reactions. Mechanism. So the HCl will form, then ferric chloride will form. That's AbCl3, ferric chloride. So mechanism of the reaction is first step is like earlier cases, chlorine. This chlorine and chlorine reacts with ferric chloride. Cl3, so here. So here you take here, then we can other cases chlorine. Okay, this chlorine negative is this FeCl3. It's become positive charge. Now it become negative charge. Then this complex again attacked by benzene ring. So let's say hydrogen here, chlorine, and FeCl3. Okay, let's write that. This positive charge, negative charge. Okay, so I take this by this, and then we got this product. So you have the intermediate carbocation is formed here, hydrogen and this chlorine and hydrogen and carbocation is formed. So this can be delocalized like earlier cases. So they are coming to this one. Then finally this carbocation can attack by this negative charge or base. Carbocation, then hydrogen, this chlorine, attacked by this. You can write this way. This chlorine, the ferric chloride is now chlorine, FeCl3. This is FeCl4. This negative charge here. So here, okay. So now this attack this from HCl and pick up the proton to get the HCl. So we get the final product. Okay. So chlorobenzene and here. Then we got this HCl plus this ferric chloride is regenerated. So this as the similar cases, just like this earlier one we have discussed in bromination also. So this is about the chlorination. Now for iodination is a bit different mechanism. We have in the case of iodination a bit different mechanism takes place. Different mechanism takes place in the case of iodination. So here also iodobenzene is formed. Here hydrogen is replaced by iodine in presence of oxidizing agent. Iodine, oxidizing agent. Okay, oxidizing agent. So it gives iodobenzene, and then ice to ice I. Okay. So this is the reaction for formulation of iodination. But mechanism is a bit different from earlier cases. So here let us see the mechanism. So iodine in contains oxidizing agent. Okay, it gives to oxidizing agent. Gives to oxidizing agent. Gives to two iodinium ion plus 2 electrons. So this again this is now electrophile. This electrophile will attack to the benzene ring. Benzene ring to the electrophile attack. Okay, benzene attacks the electrophile to keep this intermediate. A carbocation is formed. So like earlier case, you can have different type. Then this so on. So it delocalize the double bond. Then finally this loss of proton by base or a base. So we got this final product. So base. So lost this got this product. Okay, so iodobenzene. So this is a bit different as compared to earlier cases. So we have discussed this one. So now this is for halogenation reactions. Now let us come to nitration reactions. Nitration of benzene to give nitrobenzene. Okay, nitration of benzene. Nitration first. Then we'll come to sulfonation. Now first let's take up nitration. So here nitration let's take place by benzene in nitric acid in presence of sulfuric acid. SO4. So we got this nitrobenzene here. Okay, this is hydrogen is replaced by by nitro groups. So this is about nitration. So let's see the mechanism of the reaction, how this nitration takes place. So first step is this is the what do they call nitric acid. It can be represented by ISO, or you can write, okay, let's say ISO NO2 plus sulfuric acid. ISO as sulfuric. This is sulfuric acid. O is the first step is so this attack this one, then given this way. Okay, this we have done. This can have. So now then we have this. Can write this one. Ice O, then ice NO2 is positive charge. Then we have this can be written as O. You can see this one. While right here, O negative charge, yes, O is okay. This. So now this in the second step, this will lose. This will lose. Water will lose. So we got a nitronium ion, NO2. So this will lose minus water. So we got the nitronium ion. Okay. Positive charge. This is the electrophile that we can have. So this electrophile can attack to the benzene ring. Benzene ring can attack this nitronium ion. So we have here hydrogen here. So it attacks here like this. So we got a intermediate carbocation is NO2, then is positive charge here. So this will delocalize the earlier cases and so on. Okay. Then this finally this loss of this proton by reacting with these sulfonate groups. So I'll write on here that one. This one, this product, this final steps, this hydrogen NO2, then hydrogen here, positive charge. Okay, this reacts with by that ice. Oh no, this one O negative charge. That's from sulfuric acid. OS. Okay, you can write SO3S. Okay. So then sulfuric acid is regenerated. So this is the product, NO2, then sulfuric acid. So this is the general mechanism of the this is the mechanism of the nitration reaction. So I am repeating again. First step is the formation of nitrogen ion. This nitrogen ion attacked by benzene ring to give this carbocation, which can be the positive charge can be delocalized like earlier cases. And finally loss of this proton by reacting with this sulfonate ion, you got this nitrobenzene, the product. So this is about the nitration of benzene. Okay. So then let's get another one. We have sulfonation reactions. Sulfonation reactions. So aromatic, another example is sulfonation reactions. Sulfonation. So here sulfonic group is benzene reacts with benzene, okay, having this reacts with sulfur dioxide, or you can get some without sulfur dioxide also can give this replace hydrogen is replaced by sulfonic group SO3 ice. Okay, benzene sulfonic acid. This is called benzene sulfonic acid. Benzene sulfonic acid. Sulfonic acid. Okay. So this is a sulfonation of benzene. Is one of the example of our aromatic electrophilic substitution reactions. So here also mechanism we can study this mechanism of this reaction, sulfonation reactions. We can have like earlier cases we have say sulfur dioxide. You can write this way, sulfur dioxide. Okay. So reaction with sulfuric acid is earlier cases sulfuric acid. Okay. So now this pick up this proton, then will come this charge. So we can write first step is this becomes positive charge here, O, then O is okay. This positive charge here, then you can write O, SO, you can write this SO3 ice. Okay, ice SO4. Okay, negative charge. So 1, 2, 3, 4. One hydrogen here. So you can write this way also. So this is electrophile, and this is the electrophile. We can say you can write this way, electrophile SO3 ice. SO3 ice positive charge. So this is the one. So now this electrophile is attacked by benzene ring. Benzene ring attacks this one. This attacks with. You can write in a short way also. SO3 ice positive charge attacks here. So you can have a carbocation is formed. Ice SO3 ice, then carbocation is formed. This carbocation can be delocalized like earlier cases. Positive charge can be delocalized. Then final step is the loss of this proton here by reacting with the sulfonic group ice SO3 ice and hydrogen here positive charge. Okay, I think you can see. Then reacts with this ice SO4. We generated sulfuric acid is regenerated. So we got a final product SO3 ice plus sulfuric acid. So this is the overall mechanism of the sulfonation reactions. So you have now nitration, sulfonation, bromination, and chlorination, iodination. Now let us have this discuss the Friedel-Crafts alkylation, and then we can have sulfonation, Friedel-Crafts acylation, and then alkylation. So first let's look at the Friedel-Crafts alkylations. Friedel-Crafts alkylation. Okay. So here benzene is reacted with this alkyl groups, alkyl halides, and in presence of some Lewis base acid, aluminum chloride, or let's say aluminum chloride or AlX3, depends on the X. So you can get alkyl benzene. Okay, so we got alkyl benzene. So this is about the Frederick-Krafts alkylation. So benzene reacts with alkyl halides to give this alkyl benzene. Okay, so you can have acylation also. Similarly, we can have, in the case of acylation, we can have acyl groups. Acyl group will be there. So let's discuss mechanism of the reactions. So benzene reacts with RCl. This RCl, then we can have LSM. So mechanism of the reaction. Aluminum chloride. Okay, that's benzene. First, let's say X is chloride or chlorine. Okay, then first reaction with aluminum chloride, AlCl3. AlCl3. So chlorine gives this reaction like this. So we can have R positive. This is electrophile AlCl4. AlCl4. This way you can write, or in detail we can write. This way. Mechanism of the alkylation we can write, or you can write the mechanism this way. So first RCl, there are two possibilities. RCl reacts with Cl is there, aluminum chloride AlCl3. So this attacks the one. Okay, here he can have a complex R Cl, then AlCl3. Okay, negative charge, this positive charge. So now this way we can write first stop. But in some cases, so this is the react with the benzene ring attacks, then you can have the other one. But in some cases, if the alkyl group is very bulky, like this one, the bulky groups are here, RR or something like that, then this one, then we can have similar reaction. You can have this one, you can have attack this one. So you can have bulky groups or R or R, then we can have Cl, AlCl3, negative charge. Then this case, so it shall become positive charge now. So this can pick up like this. So we got a carbocation is formed here, a carbocation form, because it is very stable. It is tertiary carbocation. So it is another possible mechanism. So it depends on the position of the R is very small, like aliphatic, like ethyl, methyl, then you can have this one. Or if R is bulky groups are here, then you can have this carbocation. So there are two possibilities of this. So this electrophile. So we have electrophile here. So this electrophile reacts with benzene again. So in this next steps, these electrophiles, benzene rings, electric, like let's say this one, or RR group with this charge, then we have this simple reactions. Then CRRR, okay, alkyl groups are substituted and delocalized and so on. Then loss of this proton by this one. Then we have aluminum AlCl3, negative charge. So this attack this one, and then got this product. So we got a final product, final alkylation product. Okay, R. So this one plus HCl, and then aluminum chloride lesion attack. Aluminum chloride. Okay, this is about the mechanism of the earlier case. But in the second possibility is that second possibility of the mechanism is when the R is small groups like R, like we have discussed that one, Cl, AlCl3. So here positive charge and negative charge here. Okay. So this can, when the R like methyl group or R is equal to CH3, CH2 group, R is equal to, then like this. Okay, you can have this bulky group tertiary, then we can have different mechanism we can have also. So here take first step, attack here, attack here R, then pick up this one. Okay, so you can have hydrogen here. So carbocation like earlier case, R, then positive charge here, this localized, then one can be localized, then finally loss of this, like earlier case chlorine AlCl3, see negative charge, then attack this one, from hydrogen chloride, then product is formed. So same product. So alkyl benzene is formed. Then you can have HCl, then AlCl are generated. So the another possibilities of the mechanism. So it is about the Friedel-Crafts alkylations and reactions. So addition of the electrophile to here tertiary carbocation, and here is primary carbocation. So we have different types of mechanism for depending on the nature of the carbocation. So here we have this about the. Then you can have the sulfonation reactions. I mean, sorry, Friedel-Crafts acylation reactions. So then the acyl groups are added to the benzene ring. So to form the ketones, Friedel-Crafts acylation reactions. Acylation. Friedel-Crafts acylation reactions. So here, similarly, case in the other cases like this Friedel-Crafts alkylation, yeah, using the using these acyl groups, acyl chloride. So let's have the benzene reacts with acyl chloride, COCl, acyl chloride in presence of aluminum chloride, and for hydrolysis. For hydrolysis, you got this ketone. Hydrogen is replaced by these acyl groups. Then you can have HCl. Okay. So this is a Friedel-Crafts acylation reactions. So we can here also we can see the mechanism of the reaction. They are almost same with the alkylation, Friedel-Crafts alkylation. So here alkylation, the acyl group can be have also from other one. First step is acyl groups reacts with aluminum chloride. So then we have like earlier cases. So you can have this attack here, this attack here. Then we have RCO, Cl, Al, Cl3. So here negative charge, the positive charge. So these groups can be attacked by benzene ring, attacked by benzene ring. So here RCO, Cl, Al, Cl3, negative charge here, positive charge here. So this benzene ring attacks here, so like this. So you got this carbocation formation is expressed. So CO R, okay, link with the carbon here. Then we have positive charge here. Then so this positive charge then be delocalized, and finally attacked by this one. This one attacked by, I can write down here the product. This one, this hydrogen CO R. So here positive charge. Okay, so this can be attacked by this chlorine, AlCl4, AlCl3, negative charge, AlCl4. So the attack here, so we go to HCl, then generate the aluminum chloride. So this is the you can write this way. Okay, so from the HCl is formed, then we put a product, get carbonyl groups, ketone plus HCl plus aluminum chloride. Okay, so this is the general mechanism of the Friedel-Crafts acylation reaction. So acyl groups you can attack many times. So in some cases you can have acyl groups can be this. In some another mechanism can be also can have this. You can have this as acyl groups reaction. RCO, another mechanism. This also you can be have. So like this you can have. So you can have this RCO positive charge. This can be written as this one. This can give this one. So you can write C triple bond O like this. The oxonium ion. Okay. So delocalize. Okay. Then you can have AlCl4. Negative charge. So this another. So attacked by this acyl group attacked by the benzene ring. Then you can have this stem. So the product will be formed. So the another one. And these acyl groups can have this acylating agent. Electrophile can be obtained from epoxide also. So like another one, epoxide can be generated from like this. Okay, so this will be aluminum chloride like this. So this will give also in presence of the higher aluminum chloride, then reacts with benzene. So you can have here acid will form. The product will be COR plus another acid R CO2H. Okay, so here for another acylating groups. So acylating agent. So now I am repeating again for today's class. Okay, so we have discussed about the aromatic electrophilic substitution reaction. Benzene, I am repeating, summarizing to this one. Okay, to this lecture. So benzene itself is an electrophile, so it can undergo electrophilic substitution reactions. Benzene can react with electrophile to give this is electrophilic substitution reaction. So we can have this many types of reactions: so, halogenation, nitration, sulfonation, and then particle graphs, alkylation, and acylation. Okay. So we discuss the mechanism along with this. So when the halogenation takes benzene halogenation takes place to give the halobenzene or say chlorobenzene or bromobenzene or iodobenzene, where hydrogen is replaced by the halogens. And in the case of nitration, benzene hydrogen is replaced by nitro groups to give the nitrobenzene. Then in the case of sulfonation, sulfonic groups attack is electrophile attack by the benzene to give the benzene sulfonic acid. So we have discussed this thing. Then we can have Friedel graphs, alkylation, acylation. So using this alkyl halide, acyl chloride, etc. So we have discussed this. So today we will wind up this one. And next class we will discuss more about the reactivity, how suppose when there is some benzene substituted with another. Suppose if benzene is substituted with another say groups, say like let's say Z. Okay, then how alkylation, how this substitution reaction can take place, aromatic substitution can take place. So this will be discussed with the later on. Okay, this will be how you take by chloride or this. Suppose there is a chlorine. Suppose you want to replace this chlorine, okay, living group, then how can this replace by nucleophile or some electrophile substitution reaction? So we'll discuss this in the next class, reactivity and how this form and this. Okay. So today we'll wind up this class. The class we have like this.